Hello friend. In this video I'm going to show you how to test one sample t-test, and later we are talking about paired sample t-test and then independent t-test. But now I'm talking about one sample t-test and the confidence intervals. In this video I'm going to show you how to test one sample t-test. I wish to compare the sample mean x bar to the population mean mu. In this case, if we know the population variance sigma, we can compare the sample mean x bar to the population mean using the one sample z test. This is if we know the population variance, then we can use z-test instead of t-test. But if we don't know the population variance, then we have to use the t-test statistics. So we are going to make sure that the data tested the assumption of normality and also checked for accuracy, and make sure that the sample has been collected randomly in order to make a fair comparison between the sample mean x bar and the population mean. Now, as you can see, here we have the data. We have 10 patients collected randomly, and experiment was carried out to see whether drug A is effective in producing weight loss in individual over a period of 6 months. 10 patients were recruited for the experiment. In order to reduce the individual variability, was decided to administer a drug A to all the recruits. Therefore, each patient was weighted at the beginning. Each one out of the 10 weighted before using the drug and after using the drug A for 6 months. But in this case, we are using just interesting in the patient with the before the treatment. Then we have to set up the hypothesis for this one sample t-test. Here we have to state the hypothesis as null hypothesis. There is no difference between sample mean and population mean, or the sample mean will be equivalent to the population mean, which is x bar equal mu. Alternative hypothesis, there is a significant difference between sample mean and population mean, which means that x bar is not equal mu. So we suppose that our null hypothesis, the null hypothesis mu equal 100, which is the population mean, and alternative is mu is not equal 100. Then the second part, we have to select the significant level, which is 0.05, usually we used. Then we calculate degree of freedom, which is number of observation minus 1, and so on. Then identify the test statistic, whether we are using t statistic or z statistic, as we mentioned earlier. If we know the population variance, we can use z statistic. If we don't know the population variance, we use the t statistic. Then we formulate the decision rule or the guideline. If p-value less than 5%, meaning that we reject null and accept the alternative, meaning that the sample mean will be equivalent to the population mean, which is mu x bar equal mu. Second, if p-value greater than 5%, we failed to reject null, meaning that the sample mean is different than the population mean, which is x bar is not equal mu, the mean of the population. And finally, we state the result and arrive to the decision. Don't reject null hypothesis and reject null and accept alternative. So now, once we establish that, we can go ahead and perform the analysis with the data installed in SPSS. Now I go to SPS and open the data. As you can see it here, this is the data in SPS data with 10 and the individual were recruited for the experiment treatment before and after using the drug A in order to lose weight. So now in this part I'm going to show you how to do t-test in SPSS. Test is the simple procedure. If the two mean are significantly different, it is easy to do it in SPSS. Now I'm going to perform one sample t-test. It compares the mean. One sample t, it compares the sample mean and the population mean before the treatment. It compares the mean of our sample against some hypothesized population mean, which is mu. See if significant different or not. The key is you have to pick up your hypothesized mean according to the theory you expect it to be. Now I want to figure out how. I go to analyze, and then just I want to find the mean. Go to descriptive, then frequency, and put before to the variable, under the variable, and then just go to statistic, select the mean, and press OK. So now here the mean we can see 1 point. This is the mean for the sample, 1.0970. As we mentioned before, that if we put the null hypothesis mu equal, just I want to show you here, mu equal, as you can see it here, mu 100, and alternative is not equal 100. This is the hypothesis we are using for the analysis. I go to do one sample test. I go to analyze, compare mean, one sample test. I put the variable before the treatment, and then under the test variable, and under the test value, which is the mean of the population, as we mentioned, 100, because we said null hypothesis mu equal 100 and the alternative mu not equal 100, and then we press OK. Then here we can see the output. As you can see it here, this is the one sample test. Here you can see the number of observation 10. The mean is 109.70, standard deviation 3.3, and the standard error mean 1.06. Then here, as we can see it in the one sample, this table here, just I want to expand it to make it more clear. Then let me say 16, okay. And this is the table, as you can see it here. T, what we have here from the table, we can see that whether the mean of our sample is significantly different from the population mean. So here we have to compare the mean, as you can see it, for the sample mean with the population mean. This is the population mean. If they are different, if the mean of the sample is statistically different from the mean of the population, which is 100 or not. We look to the table, we can see that the t-value is 9.10, corresponding to the degree of freedom 9, which is n minus 1, 10 minus 1 equal 9, and then two-tailed test, p-value is less than 5%, meaning that we have a guide. What is our guide? Our guide is if p-value less than 5%, as you can see it here, just to make sure that less than 0.001. Then we can reject null hypothesis and accept the alternative hypothesis. So our p-value is equal almost 0, less than, which is less than 5, 0.01 or 0.05. We can reject null and accept the alternative, meaning that there is a significant difference between the mean of the sample, which is 109, corresponding to 100, the population mean or test value. Here we can say also what is the difference. It is easy to figure that. So if the difference is higher, if the difference, which is this one, the difference is higher, it means that there is a significant difference. So if the difference positive, as you can see it here in this case positive, it means that the sample mean is greater than the population mean. The sample mean is greater than the population mean 100. But if the difference is negative, it means that the sample mean is less than the population mean, which means x bar less than mu, or in the first one, if it's positive, x bar is greater than mu. Here I want to show you that the confidence interval C B here, as you can see, the confidence interval of the difference, lower and upper, lower 7.29 and upper 12.11. So here CI, it gives us an idea what difference might be. The CI, the confidence interval, it tells us that we are 95% certain. If the difference between the sample mean and population mean, this is tell us that additional sample that collected from the population and show the difference between the sample mean and the population mean, something between 7.92 and 12.11. Other word, confidence interval, it tells us that we are 95% certain in the difference between, this is C, confidence interval. It tells us that 95% we are confident that the difference between the sample mean and the population mean when you are dealing with the sample. This means that the majority of samples we can collect it from the population would also show this range of difference 7.29 and 12.11. So to conclude that, we could make that the sample mean was 109 or 0.70 compared with the population mean 100.100, meaning that is statistically different between the sample mean and the population mean because p-value is less than 5%. Here we can see change the confidence interval from 95 to 90, and then you can see the change from 90 to 99%. It gives us a wider range. Just one example, one extra point here. I go to analyze, compare mean, one sample mean. I leave everything as it is. Option, change 95 to 90. As you can see, the confidence interval, leave everything as it is. Press continue and OK. Here you can see the sample mean is the same as before, and here you can see t-value the same as t-value, degree of freedom, and significant. The only difference, confidence interval, as you can see it here, the confidence interval at the lower 7.29 increase to 7.75, and the upper decrease from 12.11 at 9.5 confidence interval to 11.85, and then you can change it to 99% and so on. In this case, this is the one sample t-test. If you have any comment, please leave it in the comment. I will be happy to help you as soon as I can. But here sometimes we can use the t-value on sample t-test for the Likert point. For example, if we want to go to the Likert point, let me just go to the data, and this is the Likert point. Let me say this is the consumer behavior. I want to test. First I go to analyze, compare mean, and then frequency. You can see the statistic here, the mean. Okay, press OK. You can see the mean 185. As you can see it, the mean 185 in the diagram, and this is we can put the median point between 1.5 to 2. And let me say 1.5 as a population mean. I go to analyze, compare mean, one sample test, and then we can put 1.5. This is the CV consumer behavior, and this is the population mean. Let me say 1.5, and then you press OK. You can see here the t-value is 4.59, and the degree of freedom 39, which is n minus 1, 90, 39 minus 1, 38, and the degree of the significant level, which is p-value at 2-tailed test, less than 5%, meaning that there is a positive difference between the mean of the sample and the population mean. Now you can do another thing here, increase the population mean to, say, instead of 1, put it 2, and then press OK. You can see the difference here. Here you can see there is the p-value is not greater than 5%, and the difference is the difference between the sample mean and the population mean, and this means that the population mean is greater than the sample mean, because the mean difference is negative and t-value is not statistically significant, and so on. Thank you. See you for next video. I'm going to talk about two-pair test, t-test, and independent test.